Okay, so I want to just go through and show you how to do a trade-off plot. So let's enter full screen here. All right, so here we have the Granta EduPack software, and I'm going to use the Level 2 database. What I want to do is just reproduce figure 8.9. That's the trade-off plot for the table leg. Let's just set that up and get the chart going. So I can go to chart and select. And then I want to have chart and index. So here's the thing. So we're looking at the y-axis. The y-axis on figure 8.9 is density over Young's modulus to the 1/2. So what you'll notice is that, in these categories, if you look at material properties, you're not going to see density over Young's modulus to the 1/2. You have to just kind of put that equation in yourself. And so you have to go to advanced, and then you see this box opens up. And this is a little tricky to use, but once you get the hang of it, it's fine. So we have density over Young's modulus to the 1/2. So what I need to do is I need to scroll down and find density. So I do that, and then I have to press insert. So you see there's density there, and if you can't read it, you just have to look closely at it. And once you pull it up, you'll see what's going on. Then I can divide that, use that slash for division. I'm going to have Young's modulus to the 1/2 power, so I want to set that up. I want to get some parentheses going so I could raise it to the 1/2 power. I'm going to scroll down and find Young's modulus. Again, my impulse is always to press OK. You press OK at the end. That's not going to work. You have to insert that. I'm going to close the parentheses. I'm going to use the little caret or whatever the heck that thing is called. And then I'm going to raise it to the 0.5, and you can just type that in, 0.5 power. And once your equation's set, you can press OK, and that will be the y-axis. On the x-axis, I just want 1 over the Young's modulus. So I'm just going to type in 1, and then the slash, and then Young's modulus. And insert. Now, before I go OK, I want to just mention a couple of things. You have to think ahead. It might take you a few times to get used to using this thing. The other thing is the terminology can vary. And so, for example, in the problem of the week, you got to deal with cost. Well, cost isn't here. They call it price instead. The other thing is that you won't find cost as a function of volume. You only find it as a function of mass. So it's price. Let's just see if I can find price. Yeah, there's price, US dollars per kilogram. You won't find price per volume. That's price per mass. And so you're going to have to include density in that as well to convert that to price per volume. All right, so I press OK, and now I have these two things set, and I press OK, and there I have it. Now, this it might look a little bit unfamiliar in the sense that, you don't see this great looking trade-off thing. Also, if you pull these up, that's like aluminum oxide. There's a bunch of ceramics in here. We haven't eliminated them like they did in figure 8.9. There also isn't as much going on in this region because we're only using the level 2 database, so there's not all the various types of steel. This is tungsten alloys, nickel, bronze, silver, gold, right? Things like that. So yeah, I have to look for density. There's cast iron. Yeah, the ferritic and stainless steel is there. So, there's some familiar materials. Feel free to, you can crop this to get rid of some of these outliers, make the axes bigger. You'll notice that the fonts, I've increased the font size here so I can actually read what's going on. And you can do that in the settings, and you just have to play around with it. But there's the main places are in the chart. So the tick font I've set at 18, the axis title font I set at 24, and then this labels section, these are the labels, the data labels that you pull out. I switched all of them to 18 point font, just so, again, you can see it, because otherwise things are a little bit too small. So that's the mechanics of how to do that. The other thing that you want to consider when you're doing this is what you're trying to accomplish, in the sense that, again, you're trying to make things better as you go to the origin. So you notice that on the x-axis, I have 1 over Young's modulus, because that means that as I increase stiffness, I head closer and closer to 0. I keep dividing by a larger and larger number. Because, again, the goal in these trade-off plots is to have the origin be the place that you want to be closest to. And so for my table legs, right, there's carbon fiber reinforced polymer. That's our familiar material for table legs. Here's bamboo, softwood, pine along the grain, right? So again, you don't have as much selection as you had with level 3 database, but it'll give you the idea. And this is oak along the grain, and then we have some of these green dots are steel. So that might be, you might have a trade-off surface that looks like that, and the ceramics kind of skew things because they have very high Young's moduli. Notice the highest Young's moduli material are closest to this y-axis, right? And getting closer to the origin are some of the ceramic materials. Anyway, hopefully that will get you started and allow you to figure out how to develop a trade-off plot.